Hello everyone, today I will show you an example of line charge where the formula is proved in the lecture. Okay, and so let's head towards the question right now. As we can see here, we have a charged rod levitating horizontally above the ground at z equals to 1. And the charge rod is given by linear charge density equals to positive 100 nanocoulomb per meter. And we want to find the electric field acting on point A. And so if possible, please pause the video and give a moment of consideration or even try out the question before proceeding further. Okay, so the formula is given here. Okay, it's given in professor notes, and he even explained how he got this formula. So if you need clarification, you can refer back to his notes. And actually in this formula here, our point of interest is just to find out what is the R vector here, because rho is given, epsilon naught is a constant, and that's all about it. So before we find the vector of R, let me just give you a little bit of an insight to this question. And so we are gonna see the top view, gonna see from the top of this question here, and it will be like so. This is the charge rod, and this is our point of interest A. Okay, so R vector is just basically the perpendicular distance because it's shortest of between two of them, charge rod and vector. This is our R vector. But more importantly, I just want to show you guys that the electric field acted on the point here are by the two equal but opposite length from the center of the rod, and can be dissolved into x and y direction. And as we can see here, the EY direction here are both opposite but equal, and hence they cancel each other out. We don't have any EY here, but EX on the other side is parallel to each other, and hence we will add them up. And this is true for all the little points here. And if we add them bit by bit, everything we will get equals to 2EX in the end. And that's the reason why we have 2 pi instead of 4 pi in the case of a point charge. And so let's get back to the question, how we gonna find R vector. So the R vector is kind of simple. We just have to label all the vectors that we require to solve the question here. So let me just label it quickly here. We have our vector A here, which is this vector C. We have to make this vector C because it's not provided, but we can make it fairly easy. It's just because this rod is at 0, 0, 1, the 0, 10, because it's the shortest distance, which is perpendicular to the point charge here, and 1 is the height, which is fixed. And so we want to find the R vector, and it is given that the R vector will be like so, this direction plus this direction, which is minus C plus minus C vector plus A vector will be equals to R vector. Yeah, it is. And if we just plot it, substitute in all the parameters here, we'll get the vectors 5, 0, 14 of the R vector, and hence we can just easily find the magnitude of the R vector, which is set to the 221 units. Okay, so this from here to here is set 221, and finally we just have to sub in all the values that we found here, like so. 100 nanocoulombs is a positive, but intuitively we have known this. And 2 pi epsilon naught is got constant, and 221 set square. Okay, so it's not difficult. and hence we can find out the final answer being 8.14, and the vectors are here. And as you can see here, y is 0, and indeed, as I've said just now, the y are being cancelled because they're having equal length at the opposite side, and hence will be cancelled out. And so we have our 8.14 times 5 will be our x direction here, ex, and our 8.14 times 14 is our z direction. And in total, we will get ER here. And don't forget the unit, which is Newton per Coulomb. And that's all about it. And I hope this video helps you out in figuring out how to do this kind of line charge exercises. And if you need clarification or anything else, feel free to contact me. And that's all from me, and thank you.